Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
So tying this demonstration back to the original part of this video series where we're calling into a Microsoft Visual C++ compiled DLL. Let's say that we wanted a string returned from a DLL function to populate this edit box when this form was originally shown. We want to know the name of our edit box. I named that my edit box right here. And we would want to set the text property. We could do that a number of ways. We haven't really looked at it to this point, but there is a startup function that's going to be in the name of the project. So this is your first entry point into your application code. It's not very much code here. It creates the main form, which would get renamed if we renamed our form. The class and the instance names would change. An about box in this case, and then it runs the application. So this is your first opportunity to actually call into another DLL or DLLs if you need to early on. We're going to do it in the actual form code. We'll put it in the constructor here. So my edit box text equals hello world. So ideally this is going to call that DLL function, and which returns a character constant, and it's going to put it into the text of the edit box. Now, we can't call a function that we don't know anything about. It needs to be spelled correctly. So we need to include that VCL test.h header file that we created earlier in order for it to find this header file without us specifying a path. We do need to add that path to the compiler's include search path. Directories, include file search path. C test. Now it should compile, but it's not going to link because it's not going to find our hello world symbol. Okay, let's go ahead and see that compile. Alright, so as suspected we get a link failure. So we want to add that generated import library. Again, we used implib to create it. In this case we're calling it vctest_omf.lib. So its syntax is implib, destination file, and then source file, debug, vctest.dll is our source file. And now we can add it to our project. Now it should link. It doesn't link. The name is Hello World. Oh, we need to do the implib-a. We don't need to re-add it to the project. Yeah, so that gives us our leading underscore. So now it compiles. Can't find vctest.dll. It's not in the same directory as the executable here, and it's not in the search path. So an easy way to fix that is to change the working directory when debugging. Debugger, working directory, vctest debug. That's the location of the DLL where Visual C is storing that DLL. Voila. So during startup, it called our hello world. So circling back to the calling convention issue that we addressed earlier, let's go back to this project and let's rebuild this using standard calling convention. In this case, we'll just do it with the compiler option. because we really don't have any visibility into that from header files or the DLL itself. So now it's built with standard call. If we do this implib, and then let's look at it. Oh, look, it's decorated underscore hello world at 0. That's like we described earlier. It's going to have that at sign in the with the number of bytes on the stack, and then the leading underscore. So when we try to build it, it's not going to find that symbol now because it's got a different name. One thing we can try is to go to the header file that defines this, and we'll say, oh, we're using standard call. Now, I don't need to rebuild the DLL because initially I built it by changing the global option for the calling convention. This would just be redundant. But this same header file is used in the C++ builder project, so it's going to reuse it when we rebuild. Okay, now it builds. Let's see if it runs. Hey, look, it works. And that was calling implib without the -a. What happens if I add -a? Works fine. So if I don't do -a. Works either way. So it must already have the leading underscore, and it just says, oh, that's fine. Doesn't need to add another one. And it works. Another possible approach would be to change the default calling convention in the C++ builder environment. I don't really recommend doing that because that's going to affect all of your C++, all of your C function calls, the functions you define in your code, and then any code you call in other libraries or DLLs. It's going to assume by default that they're going to be standard call if you changed it in here, but I'll show you where that is so that you know. Oh, there we go. So it's under C++ compiler, general compilation calling convention. The default is C, which correlates to cdecl. If you change it to standard call, and then let's go back to this. We don't need this anymore. And then rebuild. And run. And it runs fine. So there's at least two ways to approach that problem, but I would recommend using the keyword in the function definition if you do need to override the calling convention. Ideally, you're using cdecl. The DLL is using cdecl, and you just need the proper arguments to implib. That's that -a option. Otherwise, if it is using standard call, then you can't change it in the DLL for some reason, then you do have the ability to still use that function in your C++ builder code. Reviewing what we've learned in this video series, the output files from Visual C++ are not always compatible with C++ Builder. In particular, the object files and library files generated from Visual C++ tools are not directly compatible with C++ Builder. DLLs, however, can be compatible. You can generate a compatible import library using the C++ Builder implib tool, and then link that library file, .lib file, with your C++ Builder project. Also, it's important that both your C++ Builder code and Visual C++ agree on what the calling conventions are for the functions in the DLL that you'll be using. The two most common calling conventions are cdecl and standard call. Both of these calling conventions have an associated keyword that begins with the double underscore. When the DLL uses the cdecl calling convention, the implib tool should be called with the -a option to generate the correct corresponding import library. DLLs that are built from C++ modules should have functions using C linkage. That is accomplished using the extern C construct. An alternative method of creating a C++ Builder compatible import library is to use the C++ Builder coff to OMF utility to create OMF format import library compatible with C++ Builder. The cdecl calling convention is the default calling convention for both Visual C++ and C++ Builder. Standard call functions do not support variadic functions or variable arguments. The default calling convention may be overridden using compiler command line options. You may find these options in makefiles or project settings. Ideally, the calling convention will be specified using the cdecl or standard call keywords in a header file that is shared between the DLL and the application code. This is the Visual C++ project setting where you can override the default calling convention. Again, this is not recommended. This is the C++ Builder project setting where you can override the default calling convention. Not recommended. Memory allocated using the normal C and C++ methods like malloc and new cannot be freed in the application or vice versa. However, that allocated memory is readable and writable in both entities. Memory allocated in a DLL can be freed in an application or vice versa when using the Win32 API allocation and free functions like heapalloc and heapfree. Examples of resources that cannot be shared between DLLs and applications are open file descriptors, standard I/O file pointers, and C errno values. Resources that can be shared between DLLs and applications include open socket descriptors, handles returned from Win32 functions like openFile or createFile, and Win32 synchronization handles like events, mutexes, and semaphores. When sharing structures between applications and DLLs, it is critical that both entities agree on the alignment of the elements within those structures. The default structure alignment of both compilers may be overridden by command line options. You can find these command line options in makefiles and project settings, but the normal default is to align members on 64-bit boundaries or other natural alignment boundaries. To override structure packing on a per header file or per structure basis, you can use the pragma pack preprocessor directive. This directive allows you to store the current structure alignment value on a stack, override the structure alignment, for example, using the value 1 to specify no padding, and then restore the previous structure alignment value. The default structure alignment can be overridden in Visual C++ project settings like shown here. Again, this is not recommended. Likewise, in C++ Builder, there's a project setting for overriding the data alignment or structure alignment. When utilizing a DLL in your application, you have the fundamental design decision of whether to statically or dynamically link that DLL with your application. Statically linking results in an application that won't run without the DLL in the current working directory or in the search path. Also, the symbols that are utilized by the application must be located in the DLL at runtime. To statically link a DLL, you will require a corresponding and compatible import library or .lib file. Alternatively, you can dynamically link a DLL with your application, and in that case, the DLL need not be resident in the working directory or in the search path when the application is run. Instead, the application may, on demand, load and find addresses in the DLL and execute them. When dynamically linking DLLs, it's extremely critical that the function signature matches. Potential issues when calling DLL functions are functions that block or wait. You don't want to be blocking your application with those functions. DLL functions have different calling conventions can cause strange behavior from stack corruption. DLL functions that allocate memory without a corresponding free function can result in memory leaks, heap corruption, or assertions. If you're calling DLL functions that expect to communicate via standard I/O handles like standard in, standard out, standard error, those are likely not to work with your GUI application.